And welcome back to another episode of Tech Pro Unicorn Podcast. Today we are going to get very technical, not like deep down I's and O's, but we're going to talk about a technical topic today that is near and dear to my heart. Super excited to talk about machine learning. We're going to talk a little bit about how it's being used and where it can be used. We have Oscar Beijbom here with us. He has a Ph.D. in computer science. More importantly, he's the co-founder of Nyckel, Nyckel, if you're following along at home and want to go look them up on the web. It is a no-code platform that allows developers with no machine learning experience to quickly develop and integrate machine learning functionality into their applications. In January of 2022, Nyckel was one of 414 startups selected out of 17,000 applications. From founders around the world to be part of the Combinator Winter 2022 batch. If you're unfamiliar with that, you're probably not close enough to the tech startup sector. It's a pretty big deal. It's a way for companies to grow rather quickly with a really great support system around them, both financial and other. Oscar is also the senior director of machine learning at Motional, which is a leading autonomous vehicle company. At the company, he works on machine learning products, research, and platforms for their fleet of vehicles. Before joining Motional, Oscar was the lead developer at, you're going to have to help me with this company name.
Hövding?
Hövding, yes, yeah. Where he helped develop the AI for the world's first airbag bicycle helmet. You heard that correctly, airbag bicycle helmet. We'll talk about that. He also developed CoralNet, the largest AI platform for coral reef image analysis. So that's quite a pedigree. Thank you, Oscar, for taking the time and joining us here on the podcast.
Yeah, thanks for having me, Michael. Thanks for that introduction.
Awesome. So you were already a busy guy, right? Already kind of with a career and lots of cool projects. And you went out and found Nyckel. Talk to me about just your journey. What caused you to say, I've got to go start Nyckel?
Yeah, I mean, I do want to clarify one thing. I'm actually not at Motional anymore.
Okay.
As of about, a month and a half back. So I did, for about a year, I did both. But why did I start Nyckel? I think I've been doing applied machine learning for about 20 years for in different contexts. And I found myself constantly reinventing the wheel, right? So ML is this like, in theory, it's so simple and so beautiful, right? A universal function approximator that you give input, you give output, it learns the mapping, boom, you're done. It's so compelling, right? But in practice, it's a grind. It's just a brutal grind to get that to work as you expect it. So it's stuff like setting up, and I can go into more details later if you want, but setting up the correct data, we call it the data engine sometimes, find samples, how do you annotate them cheaply? And then you need a auto ML, it's called an auto ML system to like try, which model should you use, like which neural network should you use? And that a lot of that just comes down to, there's no really like research, just like a lot of industry best practices you need to apply. And there's a lot of pitfalls. So, right. And then once it's done, you go to the next step and you're saying, okay, now I need to deploy this model. And then there's like, you need some elastic inference infrastructure and stable, blah, blah, blah. Right. And all of that thing is just, I found myself like reinventing the wheel every job I had. And I finally said, together with Dan and George, they were sort of on the other side. They were like software engineers who thought, they kept thinking, had this feeling that machine learning was too inaccessible for them. So we said, let's just try and really put a big box around everything and make it as clean as we possibly can, and put the cleanest possible API, like a very high level abstraction on top of it. So sort of do it once and do it right. That was the main motivation for me.
Right. I love it. As we go out and consult, right, and try to introduce new technologies, AI, machine learning always come up. People have heard them. I don't think they really have a good understanding of them. Could you maybe talk about the differences between machine learning, and artificial intelligence.
Yeah, sure. So I think most people like myself that are professionals in the field would say they do machine learning because it's relatively well defined. You typically associate it with statistical machine learning, where you model essentially the statistics of the input data and how it correlates with the output data. That's sort of the statistical underpinning of that field. And it's, I can't say the theories are that great. Neural networks. No one can really put a finger on why they work so well. There's no theory. For example, I can't tell you how many times in my career people have asked me how many. Okay, I want to recognize images of cats versus dogs. How many images do I need? Even such a simple question, I can't answer because the theory is not there, right? It's always going to be, let's try 10, let's try 100, right? It depends on how difficult those images are, what kind of dog. Maybe the dogs look like cats, it's it's a very empirical field. But I still want to say that machine learning as a field is, at least well defined and has a research community and has benchmarks and so on, right? Now, AI, artificial intelligence, is not very well defined, and to me, it's mostly used sort of by marketing, big companies that want to sound fancy, so they have like an AI-powered thing. I would say if there's some sort of taxonomy, I would say AI is a little bit bigger. Like you can implement or simulate an AI using machine learning, right? Machine learning is a technology to build something that behaves like an artificial intelligence, right? But there are other ways to do artificial intelligence. For example, like these chatbots. Have you heard about the Turing test? Do you think listeners are familiar with that? Right. So you sit in front of a console, you try to figure out if the person on the other side is a human or not. Right. A lot of those, there are competitions there, and a lot of them are actually not based on machine learning as I would define it. It's more based on rule-based, sort of very pragmatic things. So that qualifies as an artificial intelligence, right? It's exactly an artificial intelligence, right? But it's not machine learning. It's not really based on the same sort of statistical modeling of input and output data. So
cool. Yeah, I think the learning curve, when I see folks get introduced to this, is they somehow think machine learning is automatic. Like,
right.
Oh, I just do this widget, I plug it in, and all of a sudden my computer's now learning and growing on its own without any context or definition, and it's just learning everything about everything, which very much isn't the case. One of the things I love on the Nyckel website, for those of you that want to follow along again at home, it's Nyckel, Nyckel.com. One of the things I love that you have out there is the video, the Nyckel in 60 seconds, because in 60 seconds, it kind of shows, sure, it highlights your product, but it shows that machine learning still has to be trained, right? It's still, you still have to give it a context, and you have to teach it just like you would a child or you building a model or a matrix, right? There's still that effort that has to go in, and then it can quote learn from there, and it can continue to grow. But I just love that video. I thought it was one of the best 60-second kind of clips on machine learning, that I've probably ever seen.
Yeah, Jeremy, who did that video, he's actually runs a very big Instagram account. He's very good at explaining things in an accessible way. And I do want to expand a little bit, because I think you bring up a really interesting topic there of, so when there's this term, something called AGI, or AGI, artificial general intelligence, right? And that's basically this utopia where there's an AI that is somehow pre-trained to do everything, and you can just deploy it, right? You can just use it for your data. And to me, that's always been a bit of a pipe dream in the field. And it got renewed, right, with all the advances we've seen in the last 5 or 10 years with deep learning. That got renewed. So you have companies like OpenAI building models like GPT-3, for example, that aspire to be this general intelligence that you can just query anything, right? And I think as a demo, as a toy, I think their API is very cool, right? You can just literally ask it anything, and you get back something that's often quite reasonable, right?
Mm-hmm.
But what our customers find is that, say they run, I have one customer that sell the event management platform from Australia, and they have, anyone can go on there and advertise their events on their platform. So when they launch in the US, they have problems with spam. Like, people just make up events, or they're not actual events, they're just advertisements for something else. And now they need
Right.
a spam versus not classifier, right?
Mm.
And the thing is that this type of spam they're seeing is very specific to them, right? There's no universal definition of, a spam message on their side might be perfectly valid information on another site, right?
Mm-hmm.
So you had this dream of having some sort of artificial intelligence to do a single one to do everything is a little bit unrealistic, I think, at least in the foreseeable future, right? But with Nyckel, they were able to say, okay, just give me some examples. Like, here's 100 examples of spam from our data, 100 of actual events on our data, and then we can do really well, because we're still leveraging all the deep learning technology, but we are just tuning it to your data.
Yep.
So that's like at a theoretical level, like that's sort of how we position ourselves versus the bigger AI houses. Let's see how it plays out.
Yeah. Well, one of the things I loved, whenever you say machine learning, in the context of like corporate IT, which are kind of like they're I always say they're keep the lights on IT departments, right? They try to do a little innovative stuff, but really they want to keep servers up, they want to maintain security,
Right.
keep their apps accessible, right? And when you go into that environment and you kind of say, hey, machine learning might be a great option here to help do some of this work, the reaction is, we could never afford it, right? There's a perception that machine learning comes with some huge expense, like you've got to hire ML development teams, and
Yeah.
you're paying top dollar, and you're competing with Google to get those people.
Yeah.
And the technology, they only think of like Microsoft, Amazon, the big houses, and that's expensive, and there's all this kind of stereotype that's associated when you
Right.
say machine learning in business, for business to take advantage of. I loved your example, right? Because you gave a very relevant example of where a business was able to deploy ML to help their in their specific instance. Maybe talk a little bit about Nyckel's model, because it's accessible, and it's transparent, which is something else I love. Right, as cool as the video is, you can also go out to the website and see the pricing
Yeah.
around Nyckel. It's not like, oh, you have to call and you have to have some consultation. It's all right out there. So I'd
Yeah.
love to just talk about that model a little bit, because I think it's a differentiator.
Yeah. What we try to do is, like, I mean, there's a pretty big space of companies that are at the surface pretty similar to Nyckel, in the sense that they provide sort of a one-stop shop. Like, Google has a product called Vertex AI, for example, that if you just read the summary, it sounds exactly like Nyckel. You define your inputs and outputs, and then it learns. But Vertex AI and most of the other platforms, they have these abstractions that we think are a little bit cumbersome, where you sort of define your data set as a separate thing. And then once you're done with that, you go and you click train, right? You sort of tell the system to train. And then you typically have to wait a couple of hours, 3 to 12 hours. And then once it's done, you come back and say, okay, cool, I want to now deploy it. And then it deploys to some sort of hardware. And then you get like your endpoint that you can call for your production system. What we did at Nyckel is we changed those abstractions. We say, okay, let's just start annotating data. As soon as you start, we need just 2 examples of every class. We'll actually train a first model for you. and we want to train it in seconds. So it takes between 1 and 10 seconds to train a model. And then that model is instantly deployed to an endpoint, right? So you can immediately go and write your integration code on the other side. Of course, the accuracy of that model is not going to be fantastic with just 2 examples each. But believe it or not, there are situations where that is actually enough, right? And if it's not, you just keep annotating, right? And you see the model improve, and we get like this sort of feedback. So a couple of things there, that we changed is that we don't charge people to train their model, right? We just do that. It's included in the price. We don't charge them for the data upload or data store. The only thing we charge them for is when they invoke the model, sort of at the very end. So it's a different take, and we're hoping it will help people really get started and really try with their own data, and reduce that barrier of entry. And then, of course, our AI, our system is not going to work for everything, right? There's going to be situations there where we don't get enough accuracy, but we've seen enough very positive experiences where people actually are able to build something quickly and put it in production.
What are some examples, just to kind of put into folks, the listeners' heads, of where potentially ML could be a good player?
Right. So we talked about one text example, right, with the spam detection. Another text example is this is actually, it almost sounds like I'm making this up, but actually a developer. So a developer in Ukraine built a site for refugees, right, internal refugees in Ukraine, for them to find shelter. So you have people can go and offer, shelter, and then people can go and seek if they're displaced from whatever the fighting is going on right now. And he went, and he had the problem where people were somehow clicking the wrong button. So he had requests ending up at the offers, and vice versa.
Right.
And then he found us through using Google search or whatever, created a function to say, this is a request and this is an offer. And in less than a day, he had it deployed to production, and he's used it to clean up his database. And that's still being used today. He has hundreds of thousands of these requests. Yeah. So, that was just so heartening to be able to help a little bit with all that nonsense going on over there, but also heartening to see that he was able to use Nyckel like that. So that's an example. Another example of text is it's actually a math assessment company. So they are writing these quizzes for math that are not based on the multiple choice. They're you sort of explain your reasoning type thing. And the reason you want to do that, I'm not an educator, but apparently it enhances your understanding of the problem if you're forced to write out your reasoning. So it kind of makes sense, right?
Right.
But then it's harder to grade, right? Multiple choice are very cheap. You can just use any technology to grade that, right? But they have manual human annotators, and he actually went on Nyckel and was able to use our system to grade his math quizzes. This is aspects of imagine just a free form math answer, and Nyckel's able to say, yes, you're highlighting this aspect, or no. And it's a startup. It's a great startup, very data driven. So they were able to say, yeah, Nyckel's actually doing quite just as well as our pool of human annotators or graders. Yeah.
That's kind of exciting.
Yeah, so that was a cool use case, I thought.
All the teachers that are listening are like, how do I do that? How do I get that? I mean, if you think about that, if you're able to spend the time up front, again, if you haven't seen how to train a model, this is a very simple model on the Nyckel website, but go watch the training that has to happen, because there is some training involved in these models. But if you put in that effort up front and you're able to use it, think about the time savings, right? Yeah. And the cost reduction by not having to pay all those annotators, or teachers could get their time back and focus less on sitting there grading papers. I remember I was at a Starbucks and I saw this teacher, and she just had this mountain of paper, and I was like, oh my God, this poor woman, and she's flipping through and marking stuff and writing stuff. imagine, like, there's no value to that other than maybe the feedback she gives the student.
Right.
But think if she didn't have to do that and she could sit and have a conversation with the student instead and
Right.
inspire them to, go on to greatness or something, right? Rather than grading tests, right? If we can automate those tasks, like, that's the magic of technology, right? That's the coolness of technology. You change people's lives. It's really, I just got goosebumps. It's really kind of cool.
Yeah. No, I love that. I love that use case. I'm very excited about that. And then so that's a couple of text examples, and most of our customers actually use the image input modality. So just a couple of examples. There's a developer in India who has some site where you can like send in your iPhone and have it. If you have a cracked screen, they will like replace the screen for you. And he's using Nyckel as part of his like ingest to say, I guess before they send it in, they have to take a picture of the screen.
Right.
And then he uses Nyckel to say, is there actually a crack in the screen or not? Like, so sort of validating user content to his site. So that's a pretty straightforward application. There's another one called Garden. They have these awesome like indoor gardens that you can grow plants inside your apartment. They're pretty sophisticated. They're like sort of equipped with watering systems and monitors and so on.
Okay.
And they needed something to be able to tell if sort of the health of the plants, right? So is this plant wilting or is it healthy? Or is it bearing fruit or not? And they were able to similarly train a Nyckel function very quickly to say, yeah, this is wilting, this is not, this is bearing fruit, or this is not.
Wow.
So, once you start thinking about it, the applications really are endless, right? Anything you want out of a photo, we can probably help you with.
So many examples, right, are starting to come on, into place where even companies that'll be like, I just tested one, right, for this health screening company to go on site at a healthcare company. They like needed a photocopy or they needed a copy of test results, and I was like, I wonder if like the model's actually trained, right? So it required 2 pages of front and back. The front I actually put as the correct document. In the back, I just put a piece of paper with a bunch of writings on it that was totally not relevant. And sure enough, it came back and it said, "I'm sorry, this is not the document it should be." And I was like, "Okay, I'm impressed, right?
Yeah.
Good, you caught me, great." And here's the real one, and off I went. But the technology I feel like has came so far so fast. I just remember a couple of years ago, Microsoft was doing the whole photo ML kind of thing, and it was like, oh, we can find pictures of your cats on your phone, and everybody was like, oh my gosh, and I'm like, that's such a stupid use, right? Like, I don't need you to find pictures of my cats on my phone. I don't care. But if you think about it, just the picture, again, going back to the Nyckel website, right? You guys are identifying like a dessert, and it's a cup of pudding. Dinner, it's a piece of salmon. And an appetizer, it's, I don't know what, it looks like maybe a little cup of soup. That could be very relevant, right? In business, you just have to think about it differently, right? When you talk about the photo identification, or I love the video identification, like, is this person happy or sad? We did something with a call center, a HR call center for a company, and we said, stop listening to all these calls, right? What you really care about is, are there any calls where somebody is sad or angry or sentiment analysis, right? That's really all you care about. You don't care about the normal calls where people are happy or normal or not upset or not asking a question. Like, stop listening to those from a QA perspective. You really want to know how your team is handling the harder calls.
Right.
And sentiment analysis is like still emerging. It's a really great use case, especially around call centers and such.
Yeah. No, I mean, in a way, it's just broadening. I mean, if you think about quote unquote traditional software engineering, say you have an API, right, in some way, or web form. I mean, the first thing you want to do there is validate the content of that data. So if someone's putting in a date, you want to make sure that it has, a year, month, and a day kind of thing on it, right? And you do that with some regex or something like that. And what ML does in this case is it just expands the type of validation you can do. So when someone puts an image, you can validate if it is an image that's relevant to your situation or not, right? So yeah, it just sort of expands the reach of what a traditional software developer can do, and that's really how we think about it at Nyckel. We try to make it API first and use language that is not so ML lingo heavy, right? We want to try and reduce what we call ML anxiety, where sometimes these platforms expose too many knobs and they show too many plots, and then if you're not in the field, you just get stressed out about all that. Right? Stressful. You're like, you worry, am I doing it the right way? Like, what am I not doing right here?
Yeah.
So we try to just do it all for you instead. Yeah.
I love it. From the developer side, right? How do they, sometimes you get ML deployed and it's got low accuracy, right? It's just not, the model is failing more than it's succeeding. What are some techniques to maybe improve that accuracy?
Yeah, I mean, you basically have two choices. You improve the model, right, or you improve the data. The model meaning the architecture of the neural network, the learning process, the algorithm used for learning. And that's typically what happens in academia. Is that's the more fun part, right? So you have public benchmark data sets that are fixed forever, and then people just spend the whole Ph.D. on improving a model for a particular data set. Now, in practice, however, it's often the data that matters the most. So if you use a AutoML system like Nyckel we have, or Vertex AI, or any AutoML system, meaning that they abstract away, they sort of tell you, given your data, we'll give you the best possible model with some asterisks. It allows you to focus on the data, which is typically the most important thing. And what do I mean by that? What are the things you can do? Well, first of all, you can add more data, right? You can make sure that your classes are relatively well balanced. So often if you have like event detection where you have a spam event or an unusual outlier versus the nominal case, you want to make sure you oversample that class so that AI gets a better, or ML gets a better read on all the classes that you're trying to model. And if you're so lucky that you already have the ML like deployed in your pipeline, you can do things like, for example, there are a lot of situations, for example, this math grading thing, where like if the machine learning system makes a mistake, you might have a sort of a low confidence decision. You have a human verifier that goes in and check, and then you can pick out those low confidence predictions, and you can feed those back and label them with the correct label. So it's basically more data, balancing out all your classes, and then like feeding back the mistakes to the system, and then it can learn better.
I love it. Yeah. I mean, I think there's such a desire, I think, around ML that's out there. I always tell people just start, right? Just do something with it, get exposed to it, and then from there, you can grow. You can grow your models. You can grow how you're using it, deploying it. One of the things I really like about Nyckel is just the accessibility, from a price point per price point of view, as well as, right, you can go out and try it for essentially free, right? You guys have a trial out there for people to go out and go, oh, okay, this is cool. So even if you're just for education, right, you can go out there and try it and be like, oh, now I have a way better understanding of ML. Which, for those of us kind of in the tech space, in this space, that's all we really want, right? The more people that understand it and understand its use cases, from an evangelism perspective, that's a big win.
Yeah, and I don't want to make this all about selling nickel, obviously, but
Yeah,
there's the free tier is actually, it's an always free tier. So if you're a hobbyist, we give you like 1,000 invokes per month for free forever. So you can if you have a hobby project, you can just build your nickel function, deploy it, and use it for as long as you want. Just wanted to call that out because it's a sort of important to us that we let people do that. And
I
then
love
if
it.
they end up using it for professional purposes, we have the $50 tier or something like that is the lowest. Yeah.
Yeah, it's just nice to, I think you find companies that are kind of on the forefront, really. They're sure they need to be funded, right, to continue to grow. But at the end of the day, it's also about socializing the technology and increasing adoption, and so it's great to see. Um, the Y Combinator, that's really kind of a cool process. Talk maybe a little bit about how you guys found the Y Combinator, why that one, what's that process like? How did you guys go through it? It's pretty exciting to be 400, one of 414 out of. I mean, those are pretty good odds.
Yeah, I mean, I have such mixed feelings. Honestly, when we were all like, we were a little bit older. I mean, we're like in our 40s, the founding team, versus I think most YC founders are younger, like to 20,
Yeah,
in the 20s, maybe some 30s. But so when we were discussing whether to apply, we were all a little bit on the fence. We all felt like, we don't really need it. We know we're seasoned already. And also the fact that they take in such big batches was a little bit of like, it's like, how can this be an exclusive, like, custom experience, or like when it
yeah,
feels like such a mass market thing. But it's mind-boggling when we realized it's 400 out of, I don't remember, but it's like
17,000.
17,000. Yeah. And then obviously once we got in, they have a good way of like, they split it up by industries and by sectors, and you have a small group of partners and then other companies that are like sort of in the same field that you can help bounce ideas off of. So no, I mean, it is. We were very fortunate to get in. I think it's a very useful program. It's like sort of helping you sanity check everything about your business. Like, are you thinking about this? I think there's like 20 different things that
Yeah,
when you start a company, and I think we had a decent handle on some of them. Others not so much. So you get this like kind of boot camp, if you will, for how to
yeah,
start a company. So that's useful because we're all first time founders.
awesome.
Yeah.
A lot of times, technologists and artists, are they're all about their craft, right? They really know the technology or the subject area, or artists really know how to create their art. They're very passionate. But then when you think about creating a business around it, marketing and scaling, that's just not what the technologist does, right? That's not their expertise. You didn't go to school for marketing or for whatever. So sometimes those things, I love how you say that. It's just kind of, are you thinking about this? Are you thinking about that?
Right.
What's the
Yeah.
plans for growth and scalability? So to me, those kind of incubators are really a great way to get a team without having to hire somebody in marketing, hire somebody over here, right?
Right.
You can kind of get the benefit without experiencing all the cost.
Yeah, and one thing they tell us, I think that's very important, is that, and I think this is pretty sort of common, perhaps, advice to if you have a founding team that is very tech heavy, is don't hire a VP of sales, right? Go do that yourself. Like, the most important thing you do as a founder is to understand and like kind of help define what your customer looks like, so that you can then inform how the product should look, right? And honestly, the more I do that, the more I enjoy it. It's like, because like you said, there is the love of the craft itself, right? If you sit down, you write a nice piece of code, and you're just so happy about it, right? And it's beautiful, it works, like, nice. But I have to say that if you're doing that, but you've already ensured that there's like someone who wants it, right? Someone who's willing to pay real money for it. That adds a whole different level. It's because now you're like using your craft, and it's like it's so satisfying. I was in the self-driving car industry for 6 years before this, building this sort of the other end of the spectrum, like one of the most sophisticated AI systems you can build, right, to drive a car through the world. But the problem there is that we hadn't deployed anything. Like we were struggling to get a MVP up and like get real customer feedback. And one of the nice things about, I think it's true for web development in general, but this sort of systems where you write to a customer and that people are using it. It's really exciting.
The autonomous driving car is always used whenever you start talking about AI. People always go like the cars, and I'm always like, I think it's interesting to watch that journey, right? Because it has probably taken longer than anyone would have thought to really get that technology, quote, deployed. There's bits and pieces, little things, I think it's coming. Here in Phoenix, we have Waymo, but even Waymo is driving around still with drivers sitting in the seat. The cars are driving, but there's still a driver, sitting behind the wheel in case something happens. We had an incident where a lady was jaywalking, stepped out between two cars and got hit by an autonomous vehicle, and passed away, unfortunately. Which really set the industry back. It was totally her fault. The car was totally in the right. She literally darted out in front of a car.
I see.
She would have been hit whether it was the autonomous driver or a human driver, if you were driving or if I was driving, right? But because it was on autonomous mode, everybody was like, see these autonomous cars, they can't be trusted. No, autonomous cars and AI still can't fix stupidity, right? If you jump out from between two cars into an oncoming lane of traffic, there's nothing autonomously that stops a car on a dime, right? There's nothing that can change physics about what we're doing with cars. How was that? I loved your, we didn't have an MVP, right? Even though you're working on something so cool, right? It's like you want to see it, touch it, right? There's satisfaction when you bring that to life.
Yeah. Yeah, and to be clear, when I say MVP, I mean like a driverless MVP. Obviously, we had fleets everywhere driving around with safety drivers, like you said, that Waymo does in Arizona. No, when I started, it's a wonderful journey in the sense that the problem that we're solving is one of the richest, the most difficult. It's sort of this open world robotics problem, right? Where you can't control that. It's the opposite of what like what I was saying earlier with Nyckel, how spam for a particular person, it's not spam for someone else. It's like a narrow AI where I think the technology does very well. The other spectrum is this open-ended problem where you don't know, you can't control the environment, and that's just crazy hard, right? And I think the field went through so many iterations, right? When I started, I was the first computer scientist in my company. It was all robotics people. So you could, the company was called Autonomy back then. It was an MIT-based startup. And you could build a self-driving car with just, quote unquote, right? It's not like that's worse or anything, but like sort of traditional, like robotics technology, right? Probabilistic robotics technologies. And that works really well in constrained environments. For example, we have mining trucks going in mines, right? A lot of those are already autonomous, and they don't, as far as I know, use a lot of machine learning, because you can use like a LiDAR point cloud and reason about the structure of the walls, and you have a map that you build up, SLAM, like simultaneous localization of map. You can build that out and know where you are and so on. So you can, but the problem is that once you start seeing these things that the LiDAR can't resolve, right? So vertical poles, for example, versus a pedestrian can be very confusing for a LiDAR. because it's just like a point, it's a bunch of points sticking out from the ground. And from a single LiDAR sweep, it could be hard to say if that's a signpost, a light post, or a pedestrian. So then you start, okay, well, then we need computer vision, right? And once you start inviting cameras on board, you're sort of giving up. You can't reason explicitly about that. When I say explicitly, I mean, if this pixel is blue and this pixel is red, it's something, right? You need to use machine learning and deep learning in particular. So now you already have a stack with deep learning in it, right?
Mm-hmm.
And that really messes things up from the perspective of like verifiability. And like, there's this sort of, if you go to Mercedes-Benz or Ford and you say how they validate all their engineering, it's this very traditional, V-shaped model where you start with the requirements, specifications, and then you build engineering, and then you validate on the other side. And that model just doesn't work when you have an AI in the loop. So I think the whole field was like struggling with this. On the one hand, every single thing that you handed over, like one of my like the team that I was with, one of the big things we were working on was applying deep learning to LiDAR point clouds. And it turns out that in the nominal case, right, in the standard case, you do so much better if you have a machine learning based method interpret that point cloud versus a sort of quote unquote traditional robotics bottoms up approach. But now you've also given up interpretability on your LiDAR pipeline. And the LiDAR pipeline is kind of like the backbone of your perception system in a robot. So you had this conflict of expanding AI because everything works better when you train these big models. It's complex enough of a function that you're trying to model that it's better. You tend to do better with more AI. But on the other hand, your executives, your safety certification people got really nervous and they didn't know how to handle that because it's just you basically end up in a world where you're never done, right? You have to have a system where you launch something and then you learn from that. Hopefully you can learn from that without actually getting into accidents, right? But you have to sort of monitor the stream of data and then continuously improve it. And that's just not how the auto industry works. They would build, validate, and launch, and then it was done, right? You'd never touched it again. So, I think that's part of the reason it's taking so long. And I'm excited to see, Cruise, I applaud their efforts. They're now, driving around San Francisco in, there's no drivers in the cars and they're expanding their areas. And I think they're doing a good job. And from what I understand, Waymo is following.
Yep.
Planning to do something as well.
It's interesting. I always say for it to really be, I love what you said about kind of all the unknown variables, right? There's so much that you just can't even, I don't know how you account for somebody jumping between two cars, right? You don't even see it on any of your sensors, and then all of a sudden it's there, right? I think as it expands and we get more autonomous driving vehicles, right? This is obviously many years down the road. Then the variability becomes less, right? Because if we have more autonomous vehicles and less human-driven vehicles, right, everything becomes more predictable. You understand what algorithms they're using. You understand like what they're doing, right? So it's almost like we need to get like the technology proven and then do some sort of big cutover, right? Like just like we did with like all these old cars that had the gas guzzling, and we were like, got to get all the gas guzzlers off the road.
Yeah.
And now we're switching over to this.
No, and I like that point, but it's just what do you do about the pedestrians? What do you do about all the bikers? And so if you start thinking along those lines, then you sort of end up saying, well, why don't we just build like light rail and have self-driving light rail cars, right? Because that is a truly sort of protected environment, right? Where it's easy. You make the problem really. Or some cities are working on like not going all the way to light rail. They just have dedicated lanes, protected autonomous vehicle lanes. And, that's another thing you can do.
I like that too.
get towards that.
Well, this is cool, Oscar. You shared really cool, just information around machine learning. Again, for those of you following along at home, go to Nyckel's website. I appreciate that Oscar doesn't want to necessarily promote Nyckel, but I'm going to because I really love the video. That video on there is really cool. 60 seconds, you'll kind of get a really good understanding of, now I understand machine learning and the training that's involved. It's got some really good use cases on there. It talks about emotion analysis, which we just kind of touched on. And then let your brain go crazy about all the possibilities where ML can change it up, both in your business or even if you don't own your own business and you're just a leader. As we look to reduce costs, as we look to do, to allow our human labor to do more important tasks, as you think about those types of things, think about machine learning and really how you can move some of that thought process to that. So, and then again, you can reach out and get a hold of Oscar via the Nyckel website as well. But Oscar, thanks for taking the time, making machine learning, which can be very complex, making it very consumable for the listeners, and spending time with us.
Yeah. Thanks for having me, Michael. It's really fun talking to you.
Awesome.